Hello, guys. I'm here again to talk about some problem-solving strategies for your math problems that you're encountering in Imagine Math. And you can use these, of course, throughout the school year as well. So today we're going to talk about this one right here. It says, write a number sentence. Okay. So we're going to talk about that today. Um, and let me pull this up. Okay, so writing a number sentence is another problem solving strategy that you can use in math. So, what is a number sentence? First of all, we know what a sentence is in grammar. It's a complete thought with punctuation, begins with a capital letter, ends with punctuation. A sentence, usually in our minds, is a literary term, a term we use in our writing or in our grammar lessons. But there's such a thing as a number sentence in math, and you're just as familiar with those as you are with regular sentences. A number sentence is just an equation with a math function and an equal sign. So, for example, 5 minus 2 equals 3. So, the math function here is subtraction. You can have subtraction, addition, and division and multiplication. For our purposes here in fourth grade, those are the functions that you could be performing. And then an equal sign, and then you have an answer on the opposite side. So in any given equation, the equal sign is sort of like the middle point of a balance scale, right? And you're in an equation, the numbers on the left-hand side are equal to the numbers on the right-hand side. So it should be a perfectly balanced equation. If I had said 5 minus 2 equals 2, my number sentence would be incorrect. So for a number sentence to work, it has to be balanced. The two sides are equal. Okay. Then, how do we use number sentences within word problems? Well, the first thing I want you to be thinking about are keywords, and this should be somewhat familiar to you as you've worked with word problems throughout your math career. You've started to learn that certain words mean to do certain functions, right? So if you see in all in a word problem. So, how many cookies did John have in all? In that case, you know that you're either going to be adding or possibly multiplying to get your answer. You're putting together numbers in all. If it has the word fewer, like Susie had 5 fewer kickballs than her friend Joan, fewer indicates that you're going to need to subtract. It's subtracting a certain amount from a larger amount. Shared equally. So you see this a lot, like if someone has a bunch of baseball cards and they're going to share them equally among 3 friends. Well, shared equally implies you're going to be dividing. Division is sharing equally. And then the last one is how many more, I think it said. How many more? So, yeah. And how many more kickballs did Joan have than Susie? Again, that implies you're going to have to do some subtraction. Okay. So just sort of remember those keywords. There's probably a few others that you know and remember and have seen. But as you're reading your word problems, you're looking for keywords. The other thing you want to do to help you with this writing number sentences or writing equations is it's really good to also use that strategy of drawing a picture or a model. Okay, so let's look at some examples. Draw a picture and write an equation. Susie bought 5 pairs of shoes. They each cost $12. How much money did she spend in all? So here we go. Right there is a keyword. Let's find out. Okay. So already because it's in all, we know that we are likely going to be doing either addition or multiplication, one of those two, right? We're putting together. So a good place to start is to draw bar diagrams. If bar diagrams don't work for you, any kind of drawing is fine, but bar diagrams are something you will see a lot modeled for you, so it's good to get familiar with those. So we can draw a bar diagram to help give us a visual of the problem. If you're like me, I have to see it in order to understand it. And sometimes our word problems can get so wordy, or there could be so many changes in the story as you're reading it, that if you don't draw it out, it's hard to really make sure you know what's going on. And this, I've spoken with a lot of you one-on-one about this with your word problems on Imagine Math. Take the time to draw it out. Use your math journal and draw it out in that where you're working it out part of the journal. So here they show this bar model and they said Susie bought 5 pairs of shoes. So they start off by drawing 5 boxes. She bought 5 pairs. So there's 1, 2, 3, 4, 5 boxes. Each box represents 1 pair of shoes. Now, if it helps you to draw a little shoe in there, like with a little high heel shoe there. No, boys, you don't want a high heel shoe, but it is Susie. Okay, I don't know. That doesn't look much like a shoe, but you can draw shoes in there if that helps you. But each of these boxes represent a pair of shoes. Then in each box, they put 12 because each pair of shoes costs the same amount, $12. So 12, 12, 12, 12, 12. So which operation will we use to solve this problem? There are a couple of options here. I mean, you could add them all together, but you can also, a little bit quicker would be to multiply, right? It says, notice that at the top of the bar graph, there is a question mark. The total goes on the top of the bar graph. So when you're drawing a bar model, you put a question mark, or you can use a variable like a letter to represent the unknown. Right now, what we don't know is how much money she spent in all. So this total is going to go here. So you can also put a variable like S maybe for shoes, or Y or X, whatever you want to use. But you can use a variable until you finish solving the problem. Okay. It says this is a multiplication problem. That's the best way to solve it. So the number 12 is repeated 5 times. So here is your number sentence. Now, when you first write this, you really should use that variable in your number sentence to begin with and then solve it. I would like to see you when you're showing me your work, I would like to see 12, which is the cost per shoe, times the 5 pair of shoes, and this all together equals, I had like, what was it, an S, I think I used as my variable, S, the total cost of the shoes. Okay, and the problem with an S is it sort of looks like a 5. So let's do C for cost, equals the letter C. So don't get freaked out when you start to see problems like this. As you're moving into 4th and 5th grade, you're going to see this more often, where a letter is just representative of an unknown number. We just use a letter until we can figure it out. And so then as you solve this number sentence or solve this equation, you know that 12 times 5 is 60. So 60, and we know it's dollars because the question was how much did it cost, equals C, or the cost of the shoes. And then always with word problems, it's a great idea to go ahead and write that out. The total cost of the shoes would be $60. Okay. Let's try another one. So Tim raises cattle. Cattle are cows, if you didn't know that. He owns 528 cows. So cows and cattle are the same thing, okay? He gives 123 to his little brother, who now has a farm. How many cattle does he have left? Okay, So your first thing you want to do is sort of look for those keywords that are going to help you know what function to perform. And here it is. How many does he have left? What does that tell you? It's likely going to be a subtraction problem. So let's look back and make sure that makes sense. Tim raises cattle. He owns 528 cows. He gives 123 to his little brother. How many does he have left? So he's given some away, and we're going to figure out how many he has left. Now, here's your bar model. Now, notice this is a little bit different. We know this number at the top. We know the total cows that he had to begin with, right? He had 528. Then he gives away 123. So they create this box where there's 123 that are going to go away. I'm just going to draw a little arrow there. We're giving those away. And they want to know how many are left of that total 528. So let's put a variable in here. We'll use C again. And this time C doesn't equal cost. C represents cows, right? That's how many cows he has left, or how much cattle he has left. All right. So for this problem, we know it's going to be subtraction, and here's the clues. Well, there's a couple of clues, really. He gives away 123, and how much does he have left? Those are two clue words in there. So let's see. This is a subtraction problem. The clue tells you to subtract, is left. How many does he have left? And then again, they're showing you the number sentence, but Miss Grossi wants you to show it with a variable first. Just get in that habit, because that's going to be a habit you have to use a lot in math in the future, so you might as well get used to it. So it was 528 minus the number he gave away, which is 123. And you're going to say it equals, and here's where your variable goes in, C for cows. And then you solve the problem. When you finish, 405 is your answer, and you really should write that out. In the end, he has 405 cows left. Remember, you're going to kind of restate that question and answer it in a sentence. All right. So here are some other examples. They're just showing you some bar models. If you had a problem that said, John has 275 basketball cards. My son now all of a sudden into basketball cards. So 275 basketball cards, and he purchases another 142 off of the internet. How many total basketball cards does he have? And obviously, or how many does he have in all? And this is how you would solve that problem. Division would be, let's see, Miss Grossi's son has 24 new basketball cards. He wants to share them equally among 6 of his friends. How many cards did each friend get? And so in division, you have the total up here, and then the number of boxes you're dividing it into here, and then the equation. So writing and drawing equations, let me go back to that, or writing a number sentence or an equation, is a strategy that helps you. That's where you're basically going to take the numbers from the story, put them into a number sentence, and solve it out. I'm going to do a second part to this video to show you sometimes you can get more complicated word problems, like 2-part ones where you have to use the strategy. And I'm just going to walk you through one of those in just a minute. If I can pause this, I'm going to pause it. If I can't, I'll just make a video. Okay, I think I successfully paused that. We will see as I work through this problem with you. Okay, we will see if this works. Okay, so here we have a couple of 2-step word problems that I want to work with you. Okay, yeah, it looks like you're still on. Okay, sorry. And let's see. There we go. Okay, so these word problems are a little more complex because they've got 2 steps to them, but these are also ones where you can write equations to help you solve it out, starting with a picture and then solving the math. Okay, so let's look at this one. At the Tasty Bakery, cupcakes cost 50 cents each. Bagels cost $1.25. How much more do 2 bagels cost than 2 cupcakes? So here they're asking you to basically do a couple of things. So let's look for some words to help us figure out what to do. All right. How much more do 2 bagels cost than 2 cupcakes? So, how much more is our keywords that lets us know we're going to have to do what? We're going to have to subtract, right? However, it's not so simple. And these are the problems that I'm seeing some of you get tripped up on because you're not reading super carefully. I'm going to scroll this down. There it is, because I need to grab this to work on drawing it for you. Okay, so cupcakes cost 50 cents each. Bagels cost $1.25. So, and then we're going to figure out how much more do 2 bagels cost than 2 cupcakes. So to help me, I'm going to draw my diagram. And we're going to do, it says we're going to have 2 bagels. So I'm going to draw this bar model with 2 boxes. Each box represents a bagel. Now, if it helps you to draw bagels in the corner, that's fine with me, but each of these boxes represent a bagel. How much more do 2 bagels cost than 2 cupcakes? So I'm also going to have 2 cupcakes, but I know from the way the question's worded that the cupcakes cost a little less, so I'm going to make them a little bit smaller. And then what I'm trying to find out is this amount right here. I'm going to kind of do a dotted line because there's going to be this difference between the two, right? So let's see. It told us cupcakes are 50 cents. Bagels are $1.25. My pen's not very good, but 25. And the other one's going to cost $1.25, right? So I've got 2 bagels. Each of them cost $1.25. And I've also got 2 cupcakes. Each cupcake is 50 cents. And so put a dot there and another 50 cents. I had to put it under because it's not really fitting inside, but you get the idea. So each of these is 50 cents. Each of these is $1.25. I'm going to try to figure out the difference. So I know I'm going to have to subtract because it says how much more. How much more lets me know that there's going to be a subtraction function involved. But I've got to do a different step first. What do I have to do first? Yeah, I'm going to have to add these 2 together, right? I've got to add together my cost of my 2 bagels, and I've got to add together the cost of my 2 cupcakes. So my equation is going to look like 2 times $1.25, because I've got that twice, right? That's my first thing I have to do. And then after I do that, I'm going to subtract the cost of 2 cupcakes. So 2 times 50 cents. So now this is getting kind of messy on here. Oop. All right, so that's actually my equation, right? And it's just the visuals up here, and then I'm just working it out at the bottom. Now, if this makes you crazy, this is too much, you can just go ahead and do this up here in your bar model, 125 plus 125, or 2 times $1.25. You could add them or subtract them. But so 125, don't know where that went. I went too far up. Darn. I think I lost it. Well, okay. So we had $1.25 plus $1.25, which would have been $2.50 is the cost of those 2 bagels. And then we have to subtract the 2 cupcakes, which were 50 cents plus 50 cents, which would be $1 altogether. So this is another equation I can use. $2.50 minus $1 is equal to the difference. How much more do bagels? Let's make it equals B. And when we solve it, B is going to be equal to $1.50. The total cost or the difference between the total cost of 2 bagels and subtracting the cost of 2 cupcakes is going to be $1.50. All right. So if you get these 2-step problems, just realize that you may have to add first and then subtract, or you may have to multiply and then subtract. You may have to do a couple of steps. So be sure that you're reading super carefully and drawing out images to help you, and then writing your equations. I hope that helps. If you need help or stuck on something, give me a message on Google Classroom or email me, and I will help you work out some of these problems. Have a good day.